So let's do an example here with decibel. Let's say that along I-35 where they are pretending they're working doing construction. Okay. All right. So we got 5 guys out here. So 5 construction workers, and they've all got jackhammers, and they are busy jackhammering the ground. Okay. And so we got 5 of them here, and we got the foreman, and the foreman here is standing here, some distance away from him, and the sound level here is going to initially be 125 decibels. Okay. So he goes off to get a cup of coffee or something, and what happens is 4 of them stop working immediately. Okay. And so the question is, what is the new sound level at this spot where the foreman used to be standing, beforehand? Okay. And so naively, students will sometimes think that the new sound level is since you have one, so you had 5 workers. Okay. Now you have 1 worker. And so that would suggest that you divide the 125 decibels by 5 and get 25 decibels. That is entirely wrong. If you do that, it is not going to be the right answer. It's going to be completely wrong. And don't even expect partial credit for that, because I'm telling you right now, that's totally wrong. This is not the right reasoning. Because the intensity dropped by 5. Not the sound level. Okay. And so to find the sound level, we need to find the original intensity. Okay. So we know that the sound level is 10 decibel log I over I naught. Okay. And so we got 125 decibels equals 10 decibel log I over I naught. So that's 12.5 equals log I over I naught. To get rid of the log, 10 to the power. So 10 to the 12.5 is I over I naught. So I is 10 to the 12.5 times I naught. Okay, so if you multiply that out, that's 3.16 watts per square meter. Okay, so the initial power per area is 3.16 watts per square meter. So the final power per area is going to be 1/5 of that. So that's going to be 0.632 watts per square meter. So that means the final sound intensity is going to be 10 decibels times the log of 0.632 watts per square meter divided by 10 to the minus 12 watts per square meter. So the final sound level is going to be 118 decibels. Okay. Notice what we had here. We had 5 workers. Okay, 125 decibels. One worker, 118 decibels. So that's only a difference of 7 decibels. And we cut by 1/5 the power, okay, and the sound intensity. And so 1/5, a factor of 5 is 7 decibels. If I had increased, by a factor of 5, I would have increased by 7 decibels. And so that's how this works. And so that's something to keep track of. In fact, if you buy an antenna, for radio purposes or TV, and you want to and look at the antenna actually labels the decibel increase in the signal strength, and so the intensity of the signal. And so, and you also can buy electronic attenuators that attenuate things by a certain decibel level. It's not just sound. This idea of decibels and increase and decrease in intensity works for any time you have any kind of intensity measure. And so, any kind of amplitude measure. I mean, this is just a way of measuring, and so this is just something to keep track of, and it's a way of logarithmic measurements of things. And so this is a common mistake that people make, is they just would divide that by 5, and obviously that's the wrong answer right there.